Now we're going to look at the energy systems. There is two energy systems. We have aerobic, which means with oxygen, and anaerobic, which means without oxygen, so at a cellular level. So in the first systems, in the anaerobic, without oxygen at a cellular level, those systems have two components. We have the first system is the PC or the CP for creatine phosphate. That's the creatine phosphate system. It's anaerobic without oxygen. It also is sometimes called the ATP, adenosine triphosphate CP system. Now, the other system is the one down the bottom there, which is the aerobic system, which means with oxygen. And that one is going to be for long distance type activities. So we're going to go through each of these systems, the PC system, the phosphate system, the lactate system, which is also part of the anaerobic system, sometimes called the glycolytic system because it's predominantly using glycogen, the stored form of glucose. And we also have the aerobic system, which means it's using oxygen within the particular, it goes through the Krebs cycle, the citric acid cycle, etc. So these energy systems, it's all about generating ATP, so generating adenosine triphosphate. So one adenosine and three phosphate ions. As you can see at the bottom here, that picture, it's one adenosine and three phosphate. And ATP doesn't last very long. Okay, so it doesn't last very long. So it's like, think about ATP like the petrol in the car. And it depends on what those other substrates are there to utilize to make more ATP. It depends on what system we're using, etc. Now, in that first system, we've got the creatine phosphate. Now, that's stored in the cross bridges of your skeletal muscle. You have a daily turnover of about 100 grams, so not a lot of creatine phosphate. So it doesn't last very long. So you need some time for that system to regenerate, etc. Now, what I need to say is all of these systems work together. So they don't work in isolation, they all work together. But it all depends on what type of activity, how long the activity is lasting, and at what intensity. So just to recap, remember we've got two anaerobic systems. The first one, ATP-CP, it's creatine phosphate. That's a phosphate system. We're just going to call it that in blue. Then you have the glycolytic system, or sometimes called the lactate system. So it's using glycogen, the stored form of glucose. And then we have, and that's in the red. And then the green system is the aerobic system, which means with oxygen, we're utilizing oxygen. Now, all of these systems, as you can see, are working together. But as you will follow that blue line, in really high intensity exercise, the first 10 to 15 seconds is going to be using this system. The system doesn't last very long because you think about this, you can't keep the intensity up. So if you were doing, say, squat jumps, you can't keep the intensity and keep getting the same height for, let's say, 5 minutes. It's not possible. You'll start to diminish. You won't be able to get that same height and intensity. So typically, activities that last 10 to 15 seconds will be using this particular energy source, but it needs to be of a high intensity. So sprinting, 100 meters, swimming 100 meters, so something that doesn't last a long time. Shot put, javelin, hitting a tennis ball, so that power just for that period of time. Resistance training or weight training is something that you would use this system. When you look at the red line, you can see it starts from the very first few seconds, but it really intensifies from that sort of 10 to 15 seconds up to 2 minutes. And this is called the lactate system or the glycolytic system, because if you think about it, it's using glycogen, the stored form of glucose. And it has, I always think it's got a medium-sized tank as opposed to that phosphate system, which has a tiny tank, but it's very powerful. and it has the ability to perform still high intensity, but not as high, and it can last for longer. So here you could think of interval training. So like a minute on high intensity and a minute off, minute on high intensity. You could do something like Tabata would be usually in the lactate system. 400-meter run, like a 400-meter sprint. Lots of sports will use all three of these, but you might be sort of in this system. Something like rowing would predominantly use, especially if it's a short duration, will use this system. But all sports, as they're progressing, will use all three. So just remember, these systems do not work in isolation, they work together. Now, the green line, this one is your aerobic system, which means with oxygen. And this one really kicks in about 2 minutes plus, depending on the intensity of the exercise, but it means it goes and goes and goes and goes and goes and goes. So think about someone who's running a marathon, long distance swimming, a hike, anything that's going for this longer, lower intensity is what's going to be burning into this system, which is the anaerobic system. So you think walk, 10-kilometer walk, marathon running, and this is all about generating lots and lots of ATPs, predominantly from fat. So this is just another way of looking at it. This could be a little bit scary if you look at the slides, so pause it and have a bit of a look. But let's go through this again. So the first system, creatine phosphate system here, generates ATP, high power system, and think 100-meter sprint, weightlifting or resistance training. Doesn't last for much longer than 10 seconds to 15 seconds. The next system is the creatine, it's not creatine, sorry, it's the lactate system, the glycolytic system, also called like glycolysis. You've also got pyruvate here as well, generating ATP. Just remember, ATP is the petrol in the car, and you're going to generate it for all three of these systems. So here, substrate, glucose, substrate here, creatine phosphate. Powerful, short duration, think boxing, that's a great example, 400-meter run, something that you can do intensity interval training. When we get to that final system, the aerobic system, think long duration, walking, 10K run, marathon, hiking, generates lots and lots of ATP through that Krebs cycle or citric acid cycle, and lots of ATP has been generated. Going back to that CP system, ATP-CP system. So adenosine triphosphate, remember 1 adenosine, 3 phosphate ions, is a high in energy compound that delivers energy instantaneously. As you can see here on the graphic on the right. Now what actually happens is, that bond breaks, and when the bond breaks, energy is created. So energy is not created or destroyed, but in this way it's actually created. It changes form. So energy is released, and you're only left then with, as you'll see as you move around this, you're left with, a muscle contraction is created. What you're left with is an ADP, which is adenosine diphosphate, so 2 phosphate ions. So as you can see, as you walk around, go to the top, you'll see creatine phosphate. It will actually donate a phosphate ion, and now it regenerates to have ATP again. So ATP is creatine phosphate is present in the muscle. It gives it that, it donates it, and it actually provides that additional energy to become ATP again. So it's replenished during rest as ATP donates the phosphate group back to creatine. Now, you might want to pause this for a moment. This is a great little one to do, of exploring the different energy systems. And here's your answers there. I was talking about the different systems, the phosphate, the lactate, the aerobic system, which each of them has, like the phosphate, just to go through it briefly, as a tiny tank, very powerful. ATP, CP is a source. In terms of substrates, it's creatine phosphate that you need to regenerate. Remember that ATP, 100-meter sprint, resistance training, shot put, explosive sports, high jump, javelin. Recovery time's around 3 minutes. There's no byproducts. Whereas we get to the lactate system, it has a medium-sized tank, powerful, not as powerful as a phosphate. You need glucose. A byproduct is lactate, and also you get hydrogen ions dumped into the stomach. 400-meter sprints, intervals, sprint cycling, stop-start games like tennis, and it lasts sort of around 15 seconds up to 2 minutes. Recovery is about 1 to 2 hours. And look, obviously you can get back into the system without that full recovery, but it's not fully recovered until that time. The aerobic system, large tank, a lot less power, so large tank, and ATP comes from fat and glucose in the presence of oxygen. Marathon running, hiking, kicks in around 2 minutes, but remember that all systems work together. Byproduct, you've got obviously CO2 as we breathe out, and water as well, and sweat. So have a bit of a look through that.